we go to Analyze, click on Fit Model. We move our lone default as our Y. It now chooses nominal logistic. We can move everything else as our X, and we will move our new validation column to the validation section. We want to target on 1. We click Run. So we see that, again, the only two determinants of a person defaulting are average balances and age. Then we could look at the AIC criteria, make a note of it, it's 508. We might want to choose models that minimize it. Or we could also do a stepwise logistical model in which jump would then be identifying what variables to include. So just finishing this through, we can look at the performance of this model by looking at our confusion matrix to begin with. So this tells us that in our validation set, it correctly identified 262 people who defaulted, missed 90. And then in the test set, the model correctly identified 188 of those who defaulted and missed 47. So now I might use this as a benchmark. I could run an algorithm to choose variables, or I might do that myself, thinking about what variables I want to include. And then the odds ratio just tells us whether each variable increases the odds. And as we saw, number less than 1 means odds go down of this variable affecting a class 1 outcome. Number more than 1 means odds go up. So here, average balance and age are actually lowering the odds of default. Others are increasing the odds of default. And then looking at the ROC curve, this tells us that our area under the curve for our test set is 0.7. Validation set is 0.66. And then the training set usually is high, it's 0.68. But what really matters is validation, test. Especially because if we run alternative models, we'll be using validation set to choose those models. And then just to recap how stepwise gets done, we will go to Analyze, Fit Model. We'll choose our lone default as our Y. We will use everything else as our X. We'll move our validation created column to the validation column. And now we will, of course, model 1, and then we choose stepwise as the option. And then in stepwise, we can do backward selection, forward selection. In forward selection, first the model which has the highest desirable characteristic, specifically the wall score, gets included, and then subsequently the models keep getting added, variables keep getting added. In backward, you can start with all the models, then you drop your weakest model, and then the next model and the next model. In mixed, model variables start like forward, but then they can be dropped afterwards as well. So it's kind of going back and forth. And so it returns the model which has average balances as the best choice. And once we have highlighted the model, we could also, at this stage, let's say that we really wanted to look at unemployed as well. I could click that, and then when I click on Make Model, it will include both of them. And the default was not just average balances. So let's actually include unemployed and then see what happens. We're going to click on Make Model, and then we click Target 1 and Run. And let's see if our model did any better. AIC is 508, which is actually a little lower than the AIC we got before. And let's look at the ROC curve. 0.72, whereas our ROC curve in the previous analysis was a little greater. So I might go with this model or the other one. So this kind of is where the ability to choose the best model among competing model comes into play. So again, when JMP ran those results, it was basing its results off the validation statistics. It did not touch test. Test was displayed after the fact. So that's why we need to keep a separate sample of test to see how the errors might be in real life where we deploy this model. So hopefully this kind of clarifies the role of validation, training, and testing in an actual predictive data mining exercise.